Okay, so here question number 1. So this is a quadratic, this is a polynomial. Okay, so they have already graphed for you. So to calculate, so use the graph to calculate and estimate the gradient of the curve at the point 2, 5, 2 marks. So what you do here, 2, this one 2, 5, this is your x value, this is your y value. So what you do, you go on the x on your graph here. This is your graph. Let me just zoom the picture. Okay, so 2 y axis 2 is here. This is your 2 here. Okay, this is your 2 here. Then 5v, we need to check the scale. So this is 2 from here up to here. I think there are 10 boxes. There are 10 small lines. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means from this point here where 2 is, you count 5 small boxes going up. So 1, 2, 3, 4, 5. So this is where 5 is. So what you do, you put a dot here, this curve here. Then you get your meter rule, you put it this side, yankara somewhere, so that you draw a line like this. The line which touches this point. Sorry, it must be a smooth, small line. It should. So the line should touch just like like that, not to, yeah. So you draw it like this. Then this is where your point is, 2, 5 here. So you choose two points this side, let's say here, and also you choose one along this line, this point here, and maybe here, this point here. Okay, so you say, what points do you have here? This side, what is your x? What is the value here at this point? This point here. So you have from here to there, that's 1. So 1.1. So because this is 10, meaning one small box is 0.1. So this is 1. So 1.1, 1.2. This is 1.3. So x 1.3, comma y is just 1 to about 3,3. Then also you come here, this is your x value. Your x value is this is 2, 2.1, 2.3, 2.4, 2.5, 2.6, 2.7. It's 2.7, comma y value, this one here. So 10 is somewhere here, this line here, this is 10. So 10, 11, 12. So it's about 12. Okay, so now this is your x2 and the y2. Okay, then this is your x1 and the y1. You see that? So now gradient, which is designated by m, simply equals to y2 minus y1 over x2 minus x1. Now note that these values would differ because you have a physical paper. You can put your meter rule and then get the correct points. For me, I'm just showing you here for the sake of demonstrating. So you say is equals to y2 is 12 minus y1 here is 3 over x2 is 2.7, then x1 x1, sorry, so the x value, all the x values are positive, but then here y value, which is 3, is negative. So negative 3. So So this is minus, this one becomes plus here. This becomes plus because you're saying, let me just do this. So because you're saying 12 minus, open brackets, minus 3. Okay, then 20, this is x here is 2.7 minus y value is positive, which is 12. Okay, which is 12. So you're getting a negative value or something. Then you calculate, you find your answer. That is when you punch, that is your gradient. Question number 1. Then question number 2. To solve the equation, now if you look at this equation, this is the equation. I think it is written somewhere there on top of the question. You find that this equation is written as y. These are your messages. So it's written y is equals to x3 plus x2 minus 5x. Now if you check, you compare this equation with this equation here, you realize that they have just put, where there is y, they have put 0. So what they are telling you is that find the value of x when y is equals to 0 using this graph here. Okay, using this graph. Now how do you find the values of x when y is equals to 0? You know that y is equals to 0 is simply equals to the x-axis. Okay, the x-axis. Then x is equals to 0 is simply equals to the y-axis. Now don't be confused. This what it means is that, like, this is the line for y, right? Y-axis. Then where there is 0, the line that cuts 0, yamu y-axis, is the x-axis, this one here. That's why we say y is equals to 0 is simply x-axis, because where at 0 in the y-axis, the only line that cuts at 0 in the way in the y-axis is x. Same, the only line that cuts at 0 at x-axis is y-axis. So they are telling you that when y is equals to 0, so what you do is go on the graph. So come on the graph, you can draw your y-axis. This is your y-axis, right, which is already drawn, sorry. So come here and draw the line y is equals to 0, which is this one, the y-axis line. Then mark the points that touches or that crosses the curve. So in this case, they have already drawn. You just mark, say, okay, there is a point here, it touches the curve. This curve here is touching the x-axis at this point, or it touches the line y is equals to 0. Also this one touches here. So this line, the y-axis, actually is called x is equals to 0. Then the y-axis, this one is called the x-axis, this one is called x is equals to 0, y is equals to 0, sorry. So you just put where this curve is crossing, is touching this line here, is touching the curve, which is this one, this curve. So this point here now, where it is touching, this side is -3 here, -3, then here is 1. So your answers, you just mark those. You just mark, you put, maybe if you can put circle or dot, then you put your answers. X is equals to -3 and o. So you should just say and x is equals to 1. Wasira ndiye answer. Bakupasa 2 marks. Very simple. Then question number B. It's a same question. Now if you compare this equation, y is equals to x to the power 3 plus x squared minus 5x plus 3. This is the equation for this curve. Okay, so if you compare this one, you realize that it is equals to x to the power 3 plus x squared minus 5x minus 5x plus 3. So all they have done is this is the same thing, right? So if this is the same thing, then they are telling you that this thing is simply y is equals to 5x. So where there is y, they have just replaced it with the 5x. Now how do you find the solution for this one? This one is also similar to what we are doing and simple. So what you do, you write a table. You put y, or let me say you put x, y. Okay, yes. So using this equation you say this y is equals to 5x. So start. You can choose few points, maybe three are enough. So you start, you say, okay, you start with 0. When x is equals to 0, y is what? Y is 0. Because when you put 0 here, 5 times 0 is 0. So y is equals to 0. Okay. Then put a negative number and a positive number, because this is a straight line. It's a linear equation. It's a straight line. So maybe I'll say, maybe you can say when x is equals to this one, it goes up to 3. You can put the last number here. So you say when x is equals to 3, y is what? Y is 15. Because 5 times 3 is 15. Then get a negative number. You can say when x is equals to negative 2. So you say 5 times negative 2, okay, is negative 10. So when x is equals to negative 2, y is negative 10. Okay. So now let me just write these numbers here. So we have x, y. Okay. These numbers here. So we have 0, 3, negative 2. You can put even negative 3 if you want. Any number. Then here 0, 15, and negative 10. Okay. So I can drop these. This way can, oh, it's gone. Okay, but I can still remember the values. So we say d x, y. So we say d when x is equals to 0, y is also 0. When x is 3, y is 15. Then when x is negative 2, y is negative 10. So you plot these points. You say 0, 0 is here, 0, 0. Then 3, when x is 3, which is this figure here, when x is 3, y is 15. So you come, this is 10 here, the count 10, 11, 12, 13, 14, 15, somewhere here. Okay. Then when x is negative 2 here, y is negative 10. So negative 10 is somewhere here. They are meeting somewhere here. Okay. So then you get your ruler, extend the line, you join. Now it will not be perfect for me because I'm not using a meter rule. Okay. So you realize that this one is cutting here, is also cutting here. Maybe here it also cut, I don't know, because it's not a meter rule. So if it cuts this curve here also, this curve here, okay, then you just get the numbers of x. So you draw a line where this new curve, so this line is y is equals to 5x. So where it touches this curve, you get your ruler and pencil, you dot to my line, you get this number here. Also same here, you get this number here. And also here you draw you get this number which is here. So you have 3 answers if it touches in 3 points. So you say x is equals to, if this is negative 20 for example, then x is equals to, maybe there I say maybe 0.5, and x is equals to, you get this line here, maybe it's 2.3 or something. So you get the correct figures when you draw per line. Okay, then number 2 or number 3, to calculate and estimate the area, use this graph to calculate and estimate the area bounded by the curve x is equals to 1. So this one is simple. What you do, x is equals to 0, sorry, so you just come ukaverenga x is equals to 0. Where is x is equals to 0? Is the y axis. You draw a line straight. If you want, you can chikazuza your graph uzafuta kumalasi, then y is equals to 0. Y is equals to 0 ni x axis, wabwera futi you draw, and x is equals to negative 2. So x is equals to negative 2 is here. So you just so now you realize that the area that is needed is this area here, this area here. Okay, so it's bounded by this. The curve is the one which is giving you the demarcation, this curve here. So yankaramonga iyi ni curve, then kuli line tubiri. So like this curve is the one giving you this boundary. Okay, you can't go beyond here because this is your boundary. You can't go beyond this. This is your boundary. So near up. So now what you do here, up, you draw. You can use either trapezium rule or the other one I've forgotten. So you draw this into small trapezia. So like this one, I think somewhere here, because it's a perfect one like that. And then here you can do like this. Here also another one. Draw as many as you can. Then use that formula. Area is equals to half, open bracket, a plus b, is it h? Forgotten. You can also Google that formula. Then your a, they get the side by counting the height here of the number of boxes, the height, also the other side. Come on, you get. So you put here, you multiply, then you add 1, 2, 3. That is your total area bounded by that one. Then b, my chatari impa ichiza kuvuta ushita download. Let me stop here and send you. Maybe and see if I can. Oh, was that for b? Now find the equation of the tangent to the curve. Y is equals x3 plus that. Now before we come to that, let me end here. Let me send you this one because it will give you headache to download, I can tell you.